We all know it's been wet, but why has it been so wet? And when will it stop being so wet? Welcome to the Met Office Deep Dive, your weekly dose of in-depth meteorological analysis, the antidote to doom scrolling. If you enjoy these in-depth videos, please don't forget to hit subscribe, hit like, send us a comment, send us suggestions on what we can cover in future deep dives. We have responded to those comments in the past and covered those topics, so keep those suggestions coming in. Every time you do so, it's like a vote for more of this sort of thing. Now, before we get bogged down in all the wet weather talk, let's take a look at something of even more impressive magnitude that happened on Monday, the solar eclipse, of course. This shows the satellite image of the Americas. Here's South America, there's Central America, and there's North America. And of course, we saw a total solar eclipse pass through Mexico into the USA and then Canada on Monday afternoon and into the evening. And you can see that by the shadow. Really impressive stuff captured by the satellites. Now, for the UK, of course, we had a vast amount of cloud covering the UK, and really the greatest amount of solar coverage was in the northwest of Scotland, where if it was cloud-free, then you might have seen 20 to 30% of the sun covered. But a more impressive partial solar eclipse is coming up for the UK, and that's happening in August the 12th to be precise, in the year 2026. So this map here shows, again, the Americas here. We've got Greenland here, Iceland, and the UK sitting here. This is showing the eclipse that we're expecting on August the 12th, 2026. And this blue zone shows the zone of total eclipse. Now that passes through Greenland into Iceland. Great view for Reykjavik, if of course the skies are cloudy, which you can never guarantee even in August in Iceland. And then, as the sun goes down across Iberia, Portugal, Spain, into the Balearics, total eclipse expected there, but really as the sun gets closer to the horizon. But for the UK itself, we're talking about, half seven in the evening. That's when we're likely to see around 90 to 96% coverage for southwestern parts of the UK. So the southwestern tip of Cornwall likely to see the greatest coverage from this particular eclipse. There's not going to be another total solar eclipse for the UK until the year 2090. 23rd of September, and this map again shows the same sort of position. North America over here, Greenland once again seeing a total solar eclipse, Iceland again not far from that blue zone, but the UK in the zone of total eclipse, Republic of Ireland as well, but really it's Devon, Cornwall, the south coast there running through Kent into northern France. So yeah, put it in your diaries, 2090. September the 23rd at, what time is that? Around 6 p.m. in the evening. So something to look forward to. Now, back to the wet weather. Hopefully it will have dried up by the year 2090. But for the time being, we're still mainly talking about rain. And it's no surprise given the pressure anomaly that we saw in March 2024. This big blue area covering virtually the whole of the UK is showing a negative pressure anomaly, about as negative as it gets on this colour scale, and really centred across southwestern parts of the UK. So this negative sea level pressure anomaly, in other words, much lower pressure than normal, was caused by a south-shifted jet stream. And this shows the position of the jet stream during March 2024, coming out of North America there, crossing the Atlantic and then diving to the south into, well, southern Spain and North Africa. Now, we've seen a lot of named storms in the southwest storm naming group. That's Spain, Portugal, France, Belgium, Luxembourg. They're up to the letter O, and it's no surprise because we've seen all these low pressure systems directed into southwest Europe during not just March, but recent seasons as well. The UK, of course, has also seen a lot of these low pressure systems move up from the southwest, and that's why southern parts of the UK have in particular seen this marked rainfall anomaly, so much wetter than average conditions. And you can see how the jet stream compares to average. This shows where you've got blue, much stronger jet stream than you'd normally expect in March, where you've got reds, much weaker jet stream than normal. So Iceland would normally get a strong jet stream at this time of year. They've had a much weaker jet stream, whilst Iberia and France, they're much stronger jet stream. So this south-shifted jet stream. What's caused the south-shifted jet stream? Well, that brings us on to sudden stratospheric warming. I know from previous episodes of the Deep Dive, a lot of people comment and ask about how sudden stratospheric warming has affected or is likely to affect our weather. And if you want to find out more about sudden stratospheric warming, there is a great explainer video on our Learn About Weather YouTube channel. But this shows the temperature as we've seen it during the last few months, basically through the autumn and the winter and into spring, at 10 hectopascals. That's the pressure level above the North Pole, which equates to about 80,000 feet above the North Pole. In other words, in the stratosphere. So this is the temperature in the stratosphere directly above the North Pole. Now, on average, that temperature dips and reaches a nadir around December, around the shortest day of the year, and then it rises again through the rest of the winter into spring and early summer. But what we've seen this season is a lot of these ups and downs, a lot of these sudden warmings in the temperature above the North Pole. And the most recent warming was through the second half of February and the start of March. That's what that shows. Why is that important? Well, it's important because that's indicative of an upset in the wind circulation surrounding the stratosphere in the North Pole. And that wind circulation, when you have very cold air directly above the North Pole in the stratosphere, you have this strong wind circulation west to east surrounding the North Pole in the stratosphere. That's the stratospheric polar vortex. But when that wind circulation becomes upset, or it even collapses or reverses, then you get a sudden spike in temperatures above the North Pole because all that cold air gets displaced. It goes somewhere else, and so you get this sudden warming, known as the sudden stratospheric warming. And what we saw, as I say, in February and early March, sudden stratospheric warming, indicative of this upset in the circulation of the stratospheric polar vortex, which then can have consequences on our very own jet stream, which I was just talking about a moment ago. And before I talk about why or how that sudden stratospheric warming has affected our weather through March, I just want to show you another thing that's quite technical, but I'll try my best to talk you through it. This is the Arctic oscillation. And the Arctic oscillation has been up and down through December, January, February, into March and April. And the line through the middle, that's the neutral oscillation. I think you just make it out there. That's what we'd call a neutral Arctic oscillation. Anything below that would be a negative Arctic oscillation. Anything above it would be a positive Arctic oscillation. And what we've seen through the second half of March is it's gone negative, and then at the start of April it's gone negative, and now it's going up significantly above that neutral line to a positive Arctic oscillation, peaking this weekend before early next week it trends backwards. And all these different lines here, well, they're showing the forecast from a number of different models. So a bit of uncertainty, but most of them are trending backwards. So what I'm getting at here is that we started April and we ended March with a negative Arctic oscillation, and that Arctic oscillation is trending towards positive later this week and into the weekend, and then it's going back to negative through next week and likely beyond. So what does that look like? Let me just quickly explain what a negative and positive Arctic oscillation look like. And we're going to look at really the bigger picture here and draw some pictures. So, on average, this is what a neutral Arctic oscillation looks like. This was discovered by a chap called Edward Lorenz, by the way, in the 1950s, and he noticed that there's this seesaw in the pressure pattern across the northern hemisphere. When you have higher than normal pressure in the Arctic and lower, I beg your pardon, should be lower pressure in the Arctic, and then high pressure at around 45 degrees latitude. Well, that's a neutral Arctic oscillation, okay? And that's what we'd normally see with our weather in the UK. And what that would normally give us is a wind circulation like that, a jet stream that runs between Scotland and Iceland, and generally westerly airflow, because of course the winds go around. Low pressure in a anti-clockwise fashion and high pressure in a clockwise fashion. So that's a neutral Arctic oscillation. But what Edward Lorenz discovered was that sometimes you can get even lower pressure in the Arctic. And when that happens, it's like a seesaw. One goes down, the other must go up. You end up with higher pressure at 45 degrees latitude. And when that happens, you get an even stronger westerly airflow. So this is known as a positive Arctic oscillation, when you have an even stronger westerly influence for the UK. Now, this means different things at different times of year. In the winter, this can mean quite stormy weather, with the strongest storms most likely passing through Iceland and northern parts of the UK, bringing some very strong winds for the likes of Scotland, and some very wet weather towards the northwest of the UK, and very mild conditions, of course, because you've got this Atlantic influence. But in the spring and summer, well, you can end up getting reasonable weather from a positive Arctic oscillation more towards southern parts of the UK, because of course you can start to see, let's just draw something else here, the influence of higher pressure just extending there from the Azores. So we've got higher pressure there. You can end up with drier and some pleasantly warm weather across southern parts of the UK. So it means different things for different places at different times of year. In the winter, yeah, more likely to get storms, especially towards the northwest of the UK. In the spring and summer, more likely to end up with reasonable weather, some warm sunshine towards the south. But other times, you might get, wipe that clean, higher pressure, there we go, in the Arctic, and lower pressure. This is compared with average, by the way. You could still have a weak high here and a weak low here. It's compared with average, so higher than normal towards the north, lower than normal towards somewhere like the Azores. And then you get quite a weak jet stream, because you've got a lower pressure difference between the two. And that could mean, if you've got a weak low here and a weak high here, just a meandering jet stream like this. That's what one scenario could look like. Another scenario, if you've got particularly high pressure there and particularly low pressure there, is a reversal of the jet stream to give you easterlies or perhaps northerlies. That's what a negative Arctic oscillation looks like. And of course, what we've seen with this south-shifted jet stream is negative Arctic oscillation, and the jet stream pointing to the south of the UK. So what essentially we've seen during recent weeks is a negative Arctic oscillation, south-shifted jet stream, higher than normal pressure towards the north of the UK, lower than normal pressure towards the south and southwest of the UK, and some very wet weather for southern areas. But there's another scenario that you can get with a negative Arctic oscillation, and that's that the jet stream is so weak that it tends to avoid the UK, and you get higher pressure across the whole of the country. So keep in mind those two scenarios when I show you the forecast as we go through the next couple of weeks, because we're trending through the next few days up to a more positive Arctic oscillation, so the stronger westerly influence, and then trending next week to a more negative Arctic oscillation. And the big question mark is whether we'll go back to a south-shifted storm track, which is one outcome from a negative Arctic oscillation, or whether we'll trend towards higher pressure across the whole of the UK. And what the model output seems to be suggesting is, let's show this first of all, these colours coincide quite well with the ups and downs of the Arctic oscillation, and these show the most likely weather patterns for each day out to the next 2 weeks. And what we've got later this week are these dark blues taking over. So this is Friday, Saturday, Sunday. The dark blues basically mean quite strong westerlies or west-northwesterlies across the UK. So fairly high confidence with that kind of pattern. Now that looks something like this. So this is those quite strong westerlies with higher pressure developing there across the Azores and extending towards the southwest of the UK, lower pressure for Iceland and into Scandinavia, and a lot of isobars on the map, so strong westerly winds. And this is your classic positive Arctic oscillation. So we're trending in this direction where it's turning drier across the south and southwest, but it's turning wetter across the north and northwest with this strong westerly airflow, bringing a lot of wet weather to the likes of Western Scotland, Northwest England, Northern Ireland, but also across the UK, because we've got this strong west influence, milder conditions overall. So that's how things are looking into the weekend. That trends towards strong westerlies. Then what you notice is these other blues start to make an appearance. At first it's these lighter blues which correspond to northwesterly weather patterns, but then coinciding with the trend towards a more negative Arctic oscillation through next week, we've got these reds and oranges starting to appear, and they are typical of more blocked weather patterns. When I say more blocked weather patterns, I mean a weaker jet stream or a jet stream that's more displaced. In other words, something that is more like a negative Arctic oscillation. And that can manifest itself in a couple of ways. One is that you've got high pressure to the north of the UK. That's what this dark red is. Another is that you can have higher pressure over Scandinavia and with easterly winds across the UK. That's what this colour is. But we've seen high pressure to the north of the UK and lower pressure to the south of the UK quite a lot during recent weeks and months, and all that's led to is a lot of unsettled weather coming up from the south, a south-shifted storm track. So are there any suggestions that it'll be any different this time? Let's take a look at the most likely weather patterns from the model output. Again, we've got through the weekend a strong westerly influence, as I mentioned. Then it transitions to even higher pressure moving into western parts of the UK, so more of a northwesterly influence for later in the weekend and into the start of next week. And even at times through next week, there are some indications that we'll get more of a northerly airflow, so some colder conditions, but still quite a number of showers. But in these situations where you've got northwesterlies or northerlies, which is the most likely trend through next week, you've got most of the showers and longer spells of rain affecting northern and northwestern Scotland, drier elsewhere, and temperatures trending downwards through the first part of next week after a mild start. Then this sort of scenario is starting to appear in the model output. Now this would coincide with that negative Arctic oscillation, and it's got high pressure slap bang over the UK, and this is for Sunday the 21st of April. And there are a lot of computer models that are now suggesting a build of pressure over the whole of the UK. But it wouldn't take much for that to sit a bit further north and allow low pressure systems to come in from the south. And we've seen so much of that during recent weeks and months, it would be foolish to rule out that. So what we could say we're fairly confident about is that the jet stream is going to move north progressively, and we're going to see the rainfall patterns shift further north than we've seen during much of March and the start of April. So rather than southern parts of the UK seeing most of the rain, it'll be northern and northwestern parts. Then it turns more northwesterly or northerly at times through next week with showery conditions and temperatures declining downwards, so a much cooler feel through next week, but some bright skies and certainly plenty of dry and fine weather in the south. It's after that that we switch more definitively to this negative Arctic oscillation that two scenarios are likely. It certainly looks likely that higher pressure will build into the north, leading to drier weather coming into the north. The main question mark for the last week of April is the extent to which that high pressure will dominate across the UK. Will it just be northern parts that see the drier weather, with southern parts still subject to areas of low pressure on a south-shifted jet stream? Or will that high pressure develop widely? Those are the main question marks, I think, for the end of April. And of course, it's a long way off. It's 2 or just over weeks away. So we'll keep you updated right here at the Met Office. But there is some hope that the weather patterns will shift at some point, and we're getting into spring. The jet stream should be getting weaker, and we should be seeing something a little more settled up here at some point, you would hope. But I just thought I'd take this week's deep dive to delve into the bigger picture, explain why it's been wet, explain the mechanisms behind that, and see how the bigger picture is changing over the next few days and weeks, because I thought it might be useful. But we'll have more detail on the day-to-day weather, of course, in our daily forecasts, and in the 10-day trend tomorrow as well. We'll cover a lot of that in more detail. So subscribe to our YouTube channel. Make sure you check those forecasts, and please do send us your comments, send us your likes, send us your subscriptions, and we'll keep trying our best to inform you on a weekly basis of everything that's going on in our atmosphere. Bye-bye.